Thank you very much, and welcome to AWS Summit London 2017. This is my favorite event of the entire year because I get to welcome so many different companies from so many different diverse backgrounds, from startup companies to small and medium-sized enterprises to large corporates and multinationals to government agencies and non-profits, just right across the spectrum. It's very exciting for us, and we're just delighted that you're here. Now today, once again, you are all record breakers. This is by far the largest event we have ever hosted here in Europe. And as I think about the first time we ever came to London with a summit, we were just beside ourselves with joy that we had 600 people show up. And now I'm delighted to say that we have more than 6,000 people here in the XL with several thousand more people streaming on the live stream. It's just an unbelievable movement that we've all created here. So thank you very much once again for being here. What's also interesting is the different levels of experience that are in the room here. So for instance, 40% of you are still evaluating cloud and evaluating AWS. And what you've asked of us is to help you get going and to introduce you to peer groups that you can learn from throughout the day. 16% of you are still running single-digit workloads on AWS. And what you've asked for today is to industrialize your strategies and build cloud-first operating models. And then 44% of the people here are either running everything they have on AWS or running multiple workloads on AWS. And what you've asked for today is to continue to optimize your environments, to continue to retire technical debt from some of the sort of legacy old guard technologies that you have, and to continue to innovate faster using the AWS developer tools. And with more than 45 different sessions to choose from today, there is something for everybody at every stage of learning. And if you haven't done so, just as a reminder, if you haven't downloaded the Summit app, then I'd encourage you to do so because it will help your day go a lot smoother. I'm also delighted to be joined by 74 of our closest friends in the form of our partners who are also our sponsors for this event. And thank you very much to all of the partners, including our platinum sponsors here, Clarinet. Your partners have always been very central to the AWS story from day one. So whether they be systems integrators or technology companies or software companies or resellers or training partners, they're a really important part to how you abstract more value from the AWS platform. Now, cloud is the new normal. This is something we hear a lot at AWS. It's probably something we say a lot at AWS. But what are the evidence points that make that statement true? Well, the first lens to look through is the AWS business itself. And as of the first quarter 2017, AWS is a $14 billion company growing at 43% year over year. I can tell you, these numbers are just unprecedented for a company with limited tenure like AWS. We're just 11 and a half years old. And it's unparalleled as a paradigm from any other technology shift we've ever seen in history. So it's a pretty good indicator that cloud is the new normal. The second lens to look through is the lens of the growth of other multi-billion-dollar technology companies to see how things are changing. And as you can see from this chart, there is a clear changing of the guard occurring, where old guard companies are not growing as fast as they used to, and in many cases are seeing negative growth on declining technology categories. And then you're seeing them being replaced by new guard companies, like the ones mentioned here, who are becoming the de facto new normal partners for our customers to work with. And interestingly, of the top 10 companies listed here, 8 of them deliver their wares as a service and are powered by AWS. So for instance, Salesforce.com runs on AWS. Workday runs on AWS. And we're eagerly anticipating the arrival of the VMware Cloud running on AWS as well. So this should be a really clear indicator to people as to how customers are thinking about their investments in technology, but also a clear indicator as to how people are thinking about their investments in talent and in skills and in training, with the center of gravity really shifting up towards these new normal cloud companies. So is cloud the new normal? Well, we believe so. And we believe that it's not just any cloud. Now, last year at this very event, with the backdrop of Brexit around us, we declared our intent to continue inward investment into the UK, and we will continue to do so into the future. And we said that we were going to launch our UK region. And sure enough, in December of last year, we opened the doors to our new UK infrastructure region, and we've just been thrilled with the response from all of you. We have now customers from the UK, but also all around the world, and from multiple verticals, in every vertical imaginable, using the AWS cloud in the UK to run their applications and store their data. And with the UK region, we now have 16 regions with 43 availability zones, and 3 more coming soon, with one in France, one in Sweden, and a second region in China coming very soon. But what I wanted to do now is to hear from one of our customers as to how they're using AWS, and also why it was important for them that AWS opened the UK region. So with that, I'd like to introduce the CTO of DVLA, Dave Perry. Come on up, Dave. How you doing? Good morning. Good morning. Dave, thanks very much for being with us today. I hope you don't mind, but I've invited several thousand people to our private one-to-one discussion here. Is that OK with you?
That's fine. It's just like the dinner table at home.
Just like the dinner table at home. OK. Why don't we start by just telling us what DVLA do, and then also what you're running in AWS?
Absolutely. So a lot of you in the room probably use our services. We're actually a canonical register of vehicles and driver licenses. And in terms of stuff that we've got in AWS, a lot of you, if you buy or sell a car, you'll use one of the services to let us know that you've sold the car, and that's a service called VMPR. We also have a service that we've recently introduced. There is a new legislative change for the new tax rates. Yeah. That complex calculation engine, that runs in AWS. We have you have to pay your taxes, so we actually have the card payment service, which kind of people spend about £2.5 billion. That kind of runs in AWS.
Yeah, it's a big system.
And also, you know, there's a thing that some people like to go onto potentially certain car websites to find out how much their vehicle's worth.
I'm familiar with such sites.
They need to get that data from somewhere. So we've actually just developed an API that has been scaled to 1 billion calls a month to deal with that. That's on the vehicle side, and then we've got drivers. So, I mean, a lot of people, they like to hire cars. There are vocational drivers, like truck drivers and coach drivers, that need to make sure that you know, they have the right to drive those. Those services to share your driving license with those organizations, that's parts of that are on AWS.
Wow.
And then if you're naughty, you might get a fine, and you've got to pay your fine. So we also got parts of that on AWS.
Am I able to ask you to scrub my name from any of those registers?
I'll look into it. Anyway, and then the last one is we have an award-winning fitness to drive, which is if you've got a medical condition that you have to come and talk to us about, we've now allowed people to tell us about that online as well. So we've got quite a bit out there.
Quite a bit. That sounds fantastic. And so what are DVLA's main challenges, and how are your department sort of geared up to overcome that?
So I think our biggest one is that you know, we've got to reduce the cost of running IT within the DVLA by 40% over the next 3 years, which you know, which is a great challenge from an IT perspective. And also, but the big one is if you include the legislative change, 3/4 of what we spend our money on is just keeping the lights on. Yeah. You know, we want to invest in new innovative services, and we won't be able to do that. So we've got to change the balance between how much it costs to keep the lights on and how much we want to spend on change. Yeah. And then the other thing as well is that and in order to do that, we need to change our legacy systems to new modern approach. And that's quite challenging when you put it into perspective. Yeah. You know, we've got 48 million drivers records. And to again, put that into some kind of context, that's 9 out of every 10 people in the UK over the age of 16. Yeah. So we've also got 41 million vehicles that we have to license, you know, and there's only 27 million households in the UK, so that's about 1.5 cars for every household in the UK. You know, and 33 million people renew their vehicle tax online.
Yeah.
So, you know, we've got, and people have to pay. They pay by direct debit. So we have 6.8 million direct debit users. Thank you very much. But, you know, we still have to kind of manage those systems whilst we're changing them. Yeah. And one of the things that we've done is we're investing in our own IT team to be able to do that. So, you know, in terms of how do we address those, 600 to 700 IT professionals and some contract resource to do that with, you know, and that's kind of part of our biggest challenge. Yeah. And, you know, the biggest opportunity for us is our cloud-first strategy. Yeah. You know, and AWS is a destination of choice for that. So,
right. So you find that you're able to attract more talent because it's an attractive thing to use all the modern tools and things.
Yeah, and it's you know, it gives us the agility to be able to deliver really quickly. Yeah. You know, and not only that, but you know, there's a whole bunch of technical guys and girls out in the audience today who will say, "Why do I want to go and work for government?" Yeah. Well, to be honest, if you can reach the size and scale that we do across the UK, then this is a really cool place to come and work.
Absolutely. So, Dave, I mentioned earlier on that we launched our UK region in December of last year. Can you tell us how that's impacted your business?
Yeah, so for us, there's kind of there's three real areas that we want to look at. The first is we're a UK government organisation, so investing in the UK and investing in UK jobs is, you know, really positive. So, you know, we want to kind of support that. The second thing is that we get marginal gains. You know, all of our customers are UK-based, so having a data center in the UK, it's, you know, it's marginal gains, but we'll take it. Thank you very much. And then the last one is really about data residency. So, you know, there is a lot of talk about where does data exist. Now, frankly, I don't want to have that conversation. I want to build new dynamic services. I want to be able to kind of get on and deliver the stuff that we want to deliver without having to debate around where does the data exist. So it takes it off the agenda.
Absolutely.
So, you know, it's great, and thank you very much for standing up the London region.
Absolutely. Well, thank you, Dave, for being here with us today. We really appreciate your partnership as usual, and it sounds like you're doing an amazing job. And go work for DVLA, I would say, if you're in the Swansea area. So thanks very much, Dave. Thanks you very much.
Take care. Yeah. Thanks, guys.
So something else that we launched this year, in January of this year, in fact, was AWS Restart. It's estimated that the digital skills gap is costing Britain £63 billion in lost GDP. And I can say that anecdotally, when I speak to AWS customers, there's a real hunger to get after more and more technical talent. AWS Restart is helping by retraining motivated people that otherwise wouldn't have found their way back into technology. And so we've partnered with the Ministry of Defense to retrain military service leavers and their families. And we've partnered with the Prince's Trust to help young people that have maybe had a disadvantaged start in life. And the goal is to train initially 1,000 people and then to place them into 1,000 work experience placements or apprenticeships or full-time jobs or whatever it is that the customers can afford. And we've been delighted with the response from our customers. And we've had some very forward-leaning companies like Sage and like Splunk and Aviva and BBC and Direct Line really leaning into the Restart program to find a way of retraining people and getting them into the workplace. But let's now hear from the people that it impacts the most. Let's run the video.
AWS Restart is a program for ex-military and young people to give them the digital skills they need to get a job.
I was working part-time on a 0-hour contract. I needed something productive to be doing.
5 years I was in the world engineers. I got injured on an exercise and had no plan for the future.
Being a veteran myself, I know how difficult it is to move from military to civilian life. He's impressed the entire company. Proactive, interested, and just very keen.
Casey has a lot of raw talent. You could see the transformation. I was very proud of him. If I had to talk to someone that was thinking about pledging work experience places, I would say do it.
I feel more ambitious, more confident, and I've actually got a real purpose now.
I do owe a lot to it. This is my future now.
I love it.
So we are extremely proud of AWS Restart and extremely proud of the people that so far have graduated into the workplace through AWS Restart. There are some of the companies involved in AWS Restart are here. Some of the graduates in the program I can see in the audience here. I'm not going to embarrass them by asking them to stand up. But I do think that it's worthy of these people and your round of applause. So if you would, for the people of Restart. And if you feel in any way compelled to get involved in AWS Restart, and I would really encourage you to do so, then please come out to the AWS booth, and we'll be only too delighted to help you understand more about the Restart program. So now, that's it from me for now, and all that remains for me to do is to thank you again very much for coming along today. I hope you have a fantastic day of learning. It's really all about learning this day. And now I'm going to hand over to our keynote speaker. Now, you know you're an icon in footballing terms, right, when you're recognizable by just one name. You know, Pele and Messi and Best and Jackson. Maybe not Jackson. In the IT world, there is one man recognizable by just one name. It's the CTO of Amazon.com. Please welcome Werner.
Thank you. Thank you, Gavin. Thank you all for being here. By the way, there's nobody else's named Werner, so that was easy, except in Germany, and I'm not even German. So thank you all for being here. Actually, I want to emphasize something that Gavin just said. It's all about education. And today, or these days, I think here at the AWS Summit, it's all about education. This is not a sales event or a sales conference. It's really about learning. And very fortunately, we have many technical sessions lined up for you where you can really do deep dives on the different technologies. But most importantly, in those sessions, and also actually in my keynote, the most important parts of that are actually your peers talking about how they're using AWS. And as Gavin already said, about 40% of you that are in this room are just here to check out AWS. You may be starting, you may be investigating, maybe already running a proof of concept, but you're really looking forward to sort of get to know more. And I think there is no better way in learning more about AWS than talking to the person next to you. 60% of you in this room are already AWS users and have a lot of experience about using AWS. And as such, feel free to share that knowledge. And as such, always when we have customers here on stage in the keynote or when they're talking in the sessions out there, we ask them to not really be a marketing speaker, but really tell the truth. How are you using AWS? What are the good sides? What are the bad sides? What are the pitfalls? This is a new world of IT. We're doing things differently now as IT professionals than, let's say, 5 or 10 years ago. Cloud has dramatically changed the way that we're operating and that we're building software. And as such, it's work in progress. We wouldn't have launched 1,000 new features and services last year if this was just status quo. Now, you're giving us so much feedback about what you want to see, what you want us to do, what new features to build, that we are continuously innovating to bring these new features to you that you're asking for. So talk to your peers and give us feedback. Give us feedback what you want to see, what the kind of things that we're doing well, or maybe the kind of things that we're not doing well, or more features that you would like to see. We thrive on that, and we're more than willing to change our roadmap based on the feedback that we're getting from you. And especially, I think now, just like Gavin said, that cloud is the new normal. But it's been like that for a few years now. And if you really looked at sort of what the impact has been of that this is the new normal, that development is very different. And so now that you're no longer constrained by any resources, whether it's your hardware or whether it's by decisions that you've made around operating systems and packaging, all of those things, those constraints have gone out of the window. Now you're free to develop in the way that you really like to develop. And that's core to AWS's mission. When we started off like this, we knew we were going to change the way that IT was being run. We're going to change the way that applications are being developed. And we also knew from the start that you would be the experts in knowing how you would want to really build your applications or really run your systems. And as such, we decided to give you a toolbox instead of telling you how to develop your software. I think IT companies from the past, or software companies from the past that offered you development tools, told you how to build your systems. This is how thou shalt develop this app. That's not how we are, because when you do that, you talk about the past. Those are the tools and the patterns of the past. The kind of things we want to do with AWS is give you the tools so you can actually build for the future, build in new ways, do new ways of development, really implement continuous integration and continuous deployment. The BBC at any time is doing about 1,000 deployments a day to 2,700 different services. Things that they couldn't do a number of years ago. Last year on stage we had Trainline. First 3 months, they did 10,000 deployments. You can only do that on a modern system that has no constraints at all. And as such, development and building is completely, radically changing. And with that, we should not put any constraints on you. And as such, you'll see a wide variety of tools and a wide variety of services that you have to choose from. But it also means that you have the choice to exactly build the way your systems you want to build, and you operate them the way you want to operate them. And there was some joke some time ago where a developer said, like, you make us feel like James Bond. And they go like, what? He said, no, you're Q, and we're James Bond. You're Q. You give us all these tools that we never had before, and then we go out in the field and we use them in every possible way, except the way that you intended them to. Yeah? By the way, I can actually totally give evidence of that. You guys are using our tools often in ways that I go like, really? Was that the best way to use them? Or is that the way that you want to do development? Which is great. Because it means that we've built our systems in such a way, with so much freedom, that you can really build the way you want to build, with having superpowers. And I think that's sort of the theme that we would like to use here. Yeah? AWS gives you superpowers. With all of these Marvel and DC Comics movies out there, I think this really resonates well. What kind of superpowers does AWS give you to really do your job? And so, in the keynote this morning, I want to sort of reflect on the past 6, 7 months, kind of new features and services that we've delivered for you. Hopefully that they will sort of inspire you to check them out or use them, or maybe you're already using them. But I think the speed of innovation and the kind of inventions that we do with AWS are very exciting. And hopefully they will excite you to build very innovative new systems as well. So to start off with the first one, the first superpower, I think, and the most important one of all of them, is force field. Security should forever be your #1 priority. Without security, we don't have a business. None of us. Protecting your business, protecting your customers, protecting your citizens should always be your #1 priority. It trumps everything. And as such, I hope that with AWS, we are giving you the tools to protect your customers in ways that you could never do before. And whether it's a kind of investment that we make at AWS to really stay ahead of the curve, to really stay ahead of, let's say, the bad actors. Remember that security is not a line in the sand that says, this is good enough. No hacker ever looked at a website and had the stamp of ISO 27001 on it and said, oh, I won't touch that. It's a continuously moving line. And at AWS, we're able to make that kind of investment to stay ahead of the line, both in terms of building new tools, as well as in the operational sense. And that way, we can always try to protect our customers in ways that they would never be able to do themselves. We've had customers, and especially customers from the financial services industries, moving over to AWS purely because of security. Because of the kind of investments that we can make at AWS, almost no other company can make by themselves. And especially not the continuous investments that we do in this. So I think one part of that is really the kind of things that we do at AWS to protect you by the infrastructure. But there's also a part where you have to protect yourselves. The days of that firewalls were good enough security, those are long gone. If a firewall was good enough security, we would still have moats around our cities. We don't do that. We protect individual pieces in our environment. And we give you these tools, whether it's about networking with VPCs or identity access management, very clear tools around roles, the ability for you to execute with least privilege. Many of you are subject to compliance. And I think the most important security tool is that of encryption. We urge you, and we've been doing this almost from day one, to encrypt at minimum your critical business data and personal identifiable information of your customers. And I think that's just good security hygiene. You should do that. Regardless whether you run on the cloud, regardless whether you run on-premise, you should encrypt your critical business data and personal identifiable information of your customers. Preferably, you should encrypt everything. But that's the minimum. And we give you the tools to do this. It makes it easy for you. I like to believe that, if you look 5, 6 years ago, still were considering HTTPS to be too expensive. Now almost all consumer websites run on HTTPS. There's no longer a question. I think the same goes for encryption. We may have always thought that encryption tools were too hard to use. I think we're getting to the point where it's becoming much more easier to use encryption tools. If you use Redshift as your data warehouse, by default, we encrypt all your data blocks with a random key, and then that set of random keys is encrypted with a master key. And you can bring your own master key. That means that you're the only one who decides who has access to your data, not us as a provider, never. And that's the position we would like to be in. We'd like you to be the decider who has access to your data. And encryption is the tool for you to use there. Importantly in all of this is that you start thinking about security from the ground up, on day one. Security by design is something that we really promote towards our customers, especially if you're building new systems, and especially if you're a startup. If you're building a consumer startup today, you have to start with thinking about security first. This really means that you have to think about what are my security requirements. What are maybe you're operating in a compliant environment. It might be that you have other services that require some compliance. Maybe you process payments. What are the security requirements towards your customers? Are you collecting certain personal identifiable information of your customers? And what are sort of the compliance, or what are the security requirements for the network and for the operating system that you operate in? What is your patching strategy? Making sure that you get patched so that you're no longer, let's say, immediately vulnerable for all sorts of attacks, including ransomware and things like that. Then take those requirements and build a secure environment. We give you all the tools. How does the map that you just made map onto the security tools that AWS gives you? Whether it's around access or network segmentation or monitoring and encryption and tools like that. Then make use of templates. Create templates to make sure that that's the way that you want to execute your systems and where your security requirements are encoded in those templates. And then do validation. Make use of AWS Inspector, for example. Inspector has a whole set of libraries around all sorts of compliance regulations and things like that that can continuously inspect your software environment whether you're still in compliance. And especially if you run a continuous development and continuous integration environment, it's important for you to continuously test whether you are still in compliance. So we give you the tools to do that. Use them. CloudTrail, where every operation on every object on each of the servers is logged for you. Make use of that. Using the alerts on that to get triggered for anomalies happening in your environment. So use that. And of course, many of you, I think it's a pest for all of us. Denial of service attacks around the world are increasing. And it's definitely a concern for many of our customers. And if I look at that, I distinguish 3 different types. One is volumetric ones, so it's basically sort of filling up the pipe with, was it ICMP controls or just UDP floods and things like that. And then there are the state exhaustion attacks, sort of TCP, SYN attacks and things like that. And then there is a small set at the top that is very unique attacks for application level, let's say level 7 attacks that are very targeted towards sort of application-specific things. Now, if you look at sort of the metrics around this, 64% is volumetric that we see around the world. About 80% is state exhaustion. So together that brings you at 82% beyond just sort of the things that are unique for your application. We protect you from all those from all but the level 7 attacks automatically. AWS Shield has been available since, has been known since last year reInvent, but actually long before that, we were already operating AWS Shield for you, such that we protect you from all volumetric and state exhaustion attacks automatically. You don't have to do anything for that. If you're a user of Shield, you probably also will be using WAF, which is the web application firewall that allows you to actually set ACLs, so allow us to, let's say, block traffic at the edge for you for certain level 7 origins and destinations. So those two things work together to protect you from almost all DDoS attacks. Now, some of you may be concerned about, let's say, very high volume attacks. And so we offer Shield Advanced for those of you who are interested in actually really getting, for example, 24/7 support around DDoS responses. Shield Advanced also has cost protections for most of your network services. You get advanced notifications via CloudWatch. And it includes the web application firewall free of charge, or at least as part of the package. So make use of this if you have particular concerns about very high volume level 7 attacks. It is becoming really a point for customers to move to AWS because security at AWS is unparalleled. It's much better and much more advanced and continuously developing in ahead of where the bad actors are. It's really sort of one of the most important points why customers are selecting AWS today. Now, another point always has been, of course, cost. Definitely in the earlier days, many of our customers have been looking for saving money because their own IT infrastructures were extremely wasteful. I mean, many years ago, I heard from many CIOs saying that in their own data centers, utilization levels, if it got to double digits, they were happy. 15, 20% was really good. And as such, you know, for them to be able to make use of sort of elastic capacity allowed them to really drive their costs down. But most customers actually, once they are on AWS, will claim that it's actually the flexibility to move fast that is the real driver for them to expand their AWS usage. And I like to call that the superpower or supersonic speed. And it's not just that you can get 100 or 1,000 servers within a matter of minutes. Of course, that's important. Supported too, especially if you need to scale up immediately. If Comic Relief last year with their Red Nose Day, for them it was important to be able to get access for that day when you're processing 300 donations a second, to get access to a huge capacity immediately and reliably, because you don't want to miss any of those donations. But you don't want this the rest of the year. For only those moments when you're really running those campaigns, you want to get access to this massive capacity immediately, the ability to move faster. Actually, next to that really moving fast, I think what is most important in the part of supersonic speed is the access to a wide range of services. Not just compute capacity and getting access to compute capacity fast. The fact that you no longer have to take an EC2 instance and put Solar and Lucene to implement your own search. That you can pick between Cloud Search and Elasticsearch. So that's what you want to do. You want to do mobile development? You want to do IoT development? You want to do X number of different types of analytics? all of these tools are available for you. Well over 90 services are part of AWS right now. The days that AWS is just compute and storage are long gone. And part of moving fast is using these advanced services to really make sure that you only have to do those things that make you unique. Many years ago, Nick Carr wrote a famous paper in Harvard Business Review called IT Doesn't Matter. Now, he didn't really mean that IT didn't matter. He meant that for many businesses, if you all have to do exactly the same IT, it is not a competitive differentiator. And as such, you should actually not be investing in it. And AWS helps you really taking away those pain points for you that are not a competitive differentiator. Implementing search is something we all have to do. There is no website, there is no mobile app that does not have search in there. It's not a competitive differentiator. Well, it is a negative one if you don't have it. But we all have to do it. You might as well make use of Cloud Search or Elasticsearch to implement that then, because that's sort of, it's a wasted time and effort if you do these things by yourself. Now, of course, there still is this small block underneath there, that blue one that says compute, storage, databases, networking. It might seem a small block, but if you explode that one, there's quite a few pieces in there. So the breadth and the depth of these services are really important for you. Just take a look at compute. Take a look at all of these services that are in there. The cool thing is with this, with all these different compute instances, families, it allows you to make mistakes. In the past, if you made a mistake with buying hardware, you would be toast because you will be stuck with it. Now today, if you make a mistake, you just choose a different instance type. You may start off with something thinking that your app will be CPU bound, may turn out to be I/O bound, or then you fix some things and it becomes network bound. You just move instance types or sizes. So if you look at all these families out here, one of the important things in all of this, actually, I find, is the number behind these family types. In the 11 years that AWS has now been active, we are already at C5, meaning this is the 5th generation of our compute-intensive environment. C5 means that we've refreshed this architecture over and over again to get you the latest, high-intensity compute combined with networking, combined with I/O systems that really match this kind of new compute environments. And whether it's the R4s or the G2s, 2nd generation of GPUs, the P2s, the general-purpose GPUs, used by many people for deep learning applications. So we continuously refresh these architectures to make sure that you have the latest and the greatest architectures available to build your applications on. Or, we had these G2s and the P2s with GPUs associated with it, in it. But many of you said, yeah, but what I really want, actually, is I want a C4 with a GPU. So we gave you elastic GPUs, which you can attach to any of these instances, to actually just add some GPU capacity to any of the apps that you're, to any of the systems that you're running. Or I like the new F1s. Turns out, hardware acceleration is really important. It's something that you can achieve if you have a really good, stable piece of software. You can actually develop it for the F1s and then load it onto it. The cool thing is you can just develop that on your desktop, load it on the F1s, and get going with it. And actually, quite a few of the FPGA images are available in the marketplace. And there's a wide range of applications in this, in this world. For example, there's an image on the marketplace that does live video encoding. And the FPGA image, if you run that, that one runs 30 times faster than equivalent software running on CPUs and GPUs. So I urge you, if you have something that requires very high performance, it's a pretty stable software environment, take a look at trying to make FPGA images for you to actually get really increase in speed and access. So quite a few companies have been able to really transform themselves because of the access to these capabilities, to boost speed and to become more agile. And I'm very, very proud and happy to invite Claire Dixon, the CIO of Downstream of BP, on stage to talk about how they're increasing agility using AWS. Claire.
Good morning. Pleasure to be here today with a room full of techies. It's not often that we get to stand in a room together with 6,000 other people that like technology as much as we do. So it's great to be here today. So at BP, we provide heat, light, and mobility solutions to 72 countries around the world. And our world is changing really quickly. So we have a responsibility to react to that, and that means continuing to provide heat, light, and mobility solutions to all of you that still have it today, but also provide it to 1 billion people in poverty that don't have it today. And that requires interesting technology to do that. In addition, climate change is upon us, and we also have a responsibility to leave a better planet for the next generation than the one that we stand in today. And that means moving us sustainably to a low-carbon future. And I'm sure you're all wondering, well, what does that mean for IT? Well, IT underpins every single part of our business at BP. Be that deep sea, desert, rigs to retail, IT underpins all of it. And as the CIO for Downstream, I feel really proud to work for a company that's going to be part of moving our planet forward. So what does that mean for cloud? We decided about 1.5 years ago that we were going to go all in cloud. We obviously wanted to reduce our cost base by closing our data centers and remove our EOSL burden. But efficiency and growth are two key pillars for our business. We need to drive efficiency in our core business that enables us to move into new business models. We didn't really know exactly what the outcomes in that would be, but I'm going to talk to you about what we've seen. We also decided that we would transform our application estate en route and take the opportunity to decommission 30% of our apps on the way. So I'm going to talk to you about an example where we've had differentiation in our business. In our refineries, we have asset economists and refinery planners that run very complex linear programs to decide which crude and feedstocks to run at any given time. And we use a software called Spiral Plan to do that. And we decided to put it in the cloud. It was one of the first apps that we put in. And believe it or not, for the same data set, the same crude and feedstock, same units, what used to take us 7 hours to run takes just over 3 minutes now. And I'm going to take a bit of a gasp there. I have to admit that I didn't really think that we'd get that out of cloud. So it has been quite revolutionary for us. And I now have a business that uses the words amazing and love in the same words as the IT systems that we provide. That's also a new feature. And I have to admit that when we talk about innovation, we don't just want IT to innovate in our company. We want the business to innovate. And if we can innovate together with the business, that's where the magic happens. So with cloud, we bought the technology, and I think we bought that we would get a reduction in our OPEX with that. What we've gained is actually business innovation beyond IT. So when somebody in the business sits with you and says, what other questions can I ask the computer? You know that you're into something good. So we're learning, and I'm telling you a nice story now, and you must think, oh, it's all been really easy. It has not been really easy. It's been a lot of work, actually. And for us as an IT organization to upskill ourselves, to use this new technology set, it's been quite a big deal. We have had to build the capability. We've had to modify our on-prem processes. And the basics around things like security monitoring in the cloud has been a big topic for us. We have loved, see the love word again, we've loved collaborating with Amazon. They've been fantastic. They bring really fantastic engineering capability, and for us, that's been a big differentiator for Amazon. They brought training to upskill our team. And I have to say, in all of our go-lives, we've got 5 SAP systems in the cloud now, production systems, 6,000 VMs. And Amazon has gone above and beyond at all of our go-lives. So we use the collaboration word when we talk about Amazon. Patching, hot topic for all of us, I think, with the security situation that we all face. And we have found that our cloud patching has been orders of magnitude faster than on-prem. And let's talk about cost, because I know that's important for everybody. We've already seen a third reduction in our cost base for SAP systems, and we're in the 30 to 40% reduction range for total IT hosting costs. And we're not really fully optimized yet, because I would say we're still learning. I think the golden nugget, though, because this is how we move our businesses forward and achieve the big ambition that I talked about up front, achieving innovation beyond IT, where you dissolve this barrier that exists often between your IT organization and the business, is where the magic happens. And maybe to Werner's point, that's where we get our Superman outfits on as a business to move things forward. And I think the elastic capacity that we get from the cloud is something that enables us to massively change and transform how we operate today. So on a final note, I know people talk about revolution with cloud. I would ask you to think about what else in life is actually cheaper, faster, and better. And there aren't many things that I can think of when we think of those things. So thank you very much. I'm sure I'll catch up with you later.
Thank you, Claire. Faster, cheaper, better. I remember a Daft Punk song that was just like that. Yeah, you can make a nice EDM song out of this. It's actually sort of typical. I mean, quite a few of our customers will be looking for either moving faster or looking for new IT capabilities, and find that along the way, they're actually reducing your cost by 30%. So you get better capabilities, you move faster, and it is cheaper. It's almost too good to be true, but it is. Yeah? When we talk about all these instance families, there are quite a few of them. Yeah, and it is often a challenge to figure out exactly which ones to pick, and we building better tools to help you in that selection process. But sometimes it's good to sort of think about what are the steps beyond that. If you look at many of the other pieces in AWS, you don't have to think about instances. You don't have to think about AZs. You don't have to think about reliability. You don't have to think about provisioning them. And so all of these servers in that particular world are invisible. So there's places at AWS, the services that give you the superpower of invisibility. Where you no longer have to worry actually truly about provisioning, about scaling up or scaling down. Where you only pay for your use, really only pay for your use, and you no longer have to run a whole batch of EC2 instances. You can really just scale with usage. And have fault tolerance built in. So almost from day one, we had these services that these days the popular name serverless applies to. And I like to believe that AWS has a complete technology platform. Remember, the breadth and the depth of our services is what makes AWS so powerful, by making use of all of these different services. That if you want to send notifications, you don't have to think about AZs, you don't have to think about scale, you don't have to think about fault tolerance. It's built in. If you want to use DynamoDB, fault tolerance is built in. You don't have to think about primaries and backups and restarts and loading backups and things like that. It's all built in. And so I think the real power came when we sort of tackled the last piece of all of this. That was with AWS Lambda. We made serverless, we made compute also serverless. The fact that you no longer need to run VMs, to actually run your code. And even with container systems, you still map the container tasks onto VMs. That's still the batch that you run. Or even though container systems often are able to reduce your cost by 50%, by much better placement of software pieces on top of your VM fleet, you still have to manage it. And Lambda gives you the ability to no longer have to manage your compute environment either. You just write your code, and you write it in JavaScript or Java or Python or .NET, and drop it in your console or use the CLI to get your code out there and just run with it. And so there's deep integration with the other services, especially with API Gateway, which makes it really powerful. And we take care of the scaling for you. You want to execute one Lambda call, or do you want to run 10,000 in parallel? It's fine. You don't have to think about how to do that. And that really sort of makes that you only pay for the compute time that you really used. Really the CPU time that you used, the runtime of your function is where you pay for. It's a very different model from, let's say, the VM model. And many of our customers have been pretty successful with using Lambda. And it's not just sort of the young technical startups that are actually adopting this. No, it's large enterprises that immediately go knowing exactly how they can exploit this. Now, FINRA is a government organization in the US that tracks all data that happens on stock exchanges, all market data, processes all of those, and used to have a massive EC2 fleet to do this for them. Now, they just run Lambda there. And billions of events arrive a day. Each event triggers a Lambda function. Same goes, for example, for Thomson Reuters. We're collecting all this information, and all of them are processed by Lambda calls. However, most of our applications do not consist of a single function. I mean, that would be too simple, if that would be the case. Now you've got coordination between functions, you have state management, you have to do fault-tolerant handoff, you do error handling, all those kind of things. That makes it hard. Yeah, that's sort of a piece that was introduced immediately with AWS. What if I want to build more complex systems? So we give you two really good tools there. Now, one of them is step functions. And step functions helps you overcome sort of the pains of this coordination. Helps you with error handling, helps you with sequencing. It gives you a visual environment where you can, for example, set a number of sequential steps after each other, each of them being Lambda functions. Or it might be that you want to have parallel steps. You want to execute all of these Lambda functions based on this particular earlier step that you've taken. Or you want to do batching, sort of if then else. If this, then go over to that one, or take this particular step over here. So step functions help you in a visual way lay out sort of the more complex applications consisting out of multiple AWS Lambda functions. The other tool is that with all these distributed systems that we're building, it becomes more and more difficult to really figure out where bottlenecks and where problems reside. Yeah, it's been a sort of holy grail for everyone always to actually really be able to get good performance information. I think dtrace, for example, on local boxes got very far, but we need sort of a similar kind of tool to be able to do this for distributed applications. Yeah, where you are able to trace over multiple different components that may live in different environments. Yeah, may live in EC2, may live in ECS, and some parts may be in Lambda. And you need to be able to sort of bring these things together. So AWS X-Ray gives you this. Basic gives you a tracing environment that you can enable, and then we give you a visual approach to actually inspecting that particular data. Now, if you look at this, over here, we have so the important thing is that's your customer experience. So the red boxes basically indicate issues, where there's 500 giving back to customers. And so you can all the way trace that back to the fact that you haven't provisioned your DynamoDB instance, your DynamoDB, with the right read and write ratios. So the throttling of DynamoDB over there all the way trickles back to sort of the customer experience that you see on this side. So use AWS X-Ray to get deep insights into your applications and do the triggering there. Now, DynamoDB, in my eyes, is one of the 7 world wonders, or make it 10 or 11. I think this is definitely the one that, hey, I'm a big fan of. It's really sort of the go-to database for many of our developers that build serverless applications. Yeah? We continuously innovate there. And DynamoDB, just this spring, released both VPC endpoints, meaning that you no longer have to go over the sort of public internet to access DynamoDB. You can do that from within your VPC. We launched time to live on rows in DynamoDB, so you can set a time to live on a particular data item, and it will get automatically purged after that. And just recently, we launched auto-scaling. So many of you have sort of very terrible, huge variable loads on your access to the database. And it was sort of hard to sort of predict kind of load capacities that you needed at DynamoDB. So we give you auto-scaling on DynamoDB, where you can automatically increase capacity based on the load that you push towards the database. Extremely important. Now, because I believe that the less management capabilities you need for these services, the better it is for you. So lots of high-velocity use cases in around DynamoDB. I want to call out Supercell here, the guys from Finland, building tremendously fun games with millions and millions of users. Their challenge is that whenever they launch a new game, on day one, they need to be able to instantly support millions of players. And it needs to be absolutely reliable and fault-tolerant and scalable and good performance. Because otherwise, you know, all these years or months or years of game development are wasted. And so they base all of their systems on DynamoDB. Now, one challenge that we've had with DynamoDB is that we see a whole range of new applications coming to life, especially those that require milliseconds response time instead of microseconds response time instead of milliseconds. Ad tech, automatic trading, gaming, requiring much lower latencies than what you normally see out of any, just driven by speed of light. And so what we've seen there is customers have built pretty complex environments. They're building their own caches, and these caches then often have very different interfaces than the DynamoDB has themselves. So your application code needs to be aware that these caches live there. And it's really built really complex sort of systems. And so for that, we've launched recently DynamoDB Accelerator, which is a in-memory cache that you can put in front of DynamoDB by just one click of a button in the console. And it drops down your response times from milliseconds to microseconds. One click. It automatically replicates, of course, over different availability zones, sits in front of all of your DynamoDB instances. And most importantly, it has exactly the same interface as DynamoDB. The only thing you need to do is change your endpoint, and you can actually make use of your DynamoDB Accelerator and immediately go from milliseconds to microseconds response times. Yeah, 10x faster, easily to do. Another environment I think that is really driven by sort of serverless is the whole world of IoT. More and more we see many of our customers instrumenting complete production floors, supply chains, things like that. So we built an environment that is truly serverless. It's called Amazon AWS IoT, and let's look at sort of the building blocks that are in there. Starts off with having a device gateway. Basically, the gateway that all devices can communicate to securely. There's a device SDK that lives on the devices. You push X509 certificates to them so that you can have authentication and secure communication between the devices and the device gateway. At the back end of that, the messages that come through the device gateway are pushed to what's called a rules engine, where in very simple, let's say, declarative sort of SQL-like language, you can say, if temperature goes over 30 degrees, open the window. Yeah, so that you don't even have to run very complex application logic. But much of this is actually also used to then push the messages towards the application or the services that they actually need to go to. Communication back to the devices goes through something called the device shadow. Quite a few of these devices out in the wild will not be connected all the time, And as such, that makes it very difficult to build your applications if you need to figure out whether they're connected first. So we give you a device shadow that's always on. You can communicate with as if the device is alive. If the device is actually connected, we'll immediately push it through to the device. And otherwise, whenever the device comes back online, it will pick up the instructions for it. You can also pick up sort of the latest state from the device shadow. And so your application will talk to that. All of that, of course, has a nice API around it. And we also give you a device registry so that, for example, I can ask, give me all the lamps in this room, assuming I have, of course, the right authorization to ask that question about these devices. Yeah, so let's take a look at some of these pieces. I like the rules engine very much. It makes it very easy to actually build this. You can do filtering, transforming of these messages. You can do immediate reactions. You can move messages to other topics and things like that and push them into other applications, such as, of course, all the AWS services out there. The power of all these systems is the deep integration with all the other services. If you look at, for example, the integration with some of this, I like the Elasticsearch ones. You may have lots of trucks on the road that actually update sort of their location and the status, push it into the device gateway, which then push it into the rules engine, moves it over to Elasticsearch in JSON, and poof, you can, using Kibana, create nice sort of dashboards with this. I really like Elasticsearch and the visualization capabilities that come with it. Many people are not using Elasticsearch for search, but using it really as a real-time processing engine for much of the data and visualization. Yeah, or you can push it into ML engines, machine learning engines, something that happens quite a bit as well. And there's a very unique side of all of our IoT today, I think, where in the past, control pieces on much of these large machinery were very big sort of IT systems in there. These days, they're massive distributed systems by themselves. And for much of those, you actually don't want this data to actually flow back to the cloud. You really want it to stay local. Yeah, it's both in terms of physics, it's harder to move them back because there's quite a few messages, as well as just, they don't need to. Yeah, it's just purely for control on the devices itself. And so, in that sense, you have sort of these three different pieces. You have the things, the cloud, and the applications that you're running. And so we've already talked about sort of the cloud piece of this, but on the devices itself, you might actually want to have exactly the same capabilities locally as that you have in the cloud. So for that, we give you AWS Greencast that basically runs an almost complete AWS IoT system, but on sort of the gateway that you put near these devices locally. Which gives you still the same SDKs. It gives you Lambda, so you can actually write your applications in Lambda that run on the devices itself. With all of this, with all of this data flowing around, you need to store it somewhere. Yeah, we already talked about DynamoDB, sort of being a modern database. But many of us, and including ourselves, we still need relational databases. And with that, I always think about that as having the superpower of flight. I would really like to fly away from them. At least not necessarily because of the technology, but just because how the vendors have behaved over time. If I really think about these all-world databases, they're expensive, and most of all, the licensing is so restrictive. I used to buy many of these databases, and the only way to reduce cost of that was to make very long-term contracts. And to make these long-term contracts are often overscaled. Now, I would easily buy 20-25% more licenses than I would ever need, just to avoid to get into this punitive stage where you get this auditing and where you get massive punishment for using too many licenses. Such a customer-unfriendly business, which is one of the reasons that many of our customers, if they think about migrating their databases, they don't stick with these commercial on-premise databases in the cloud. They're actually moving over to these open source databases. The target of many of these migrations are either MySQL or MariaDB or Postgres. And especially Postgres is really popular because they're so semantically similar to the way, for example, that Oracle runs their databases, that it makes the transition very easily. And so to make it easier for our customers, we've built a service called the database migration service. And since the launch of that service, we've migrated 28,000 databases from on-premise into the cloud. And many of those are going from a commercial on-site database into a database with an open source interface. Yeah. We also help you there with automatic schema conversion and things like that. And it's not just relational databases, we have targets for Redshift and for DynamoDB as well. A target has been in all of this, when talking about this sort of open source databases, customers started to ask us, yes, we would like to migrate to them, but we really would like to have these enterprise features in terms of reliability and performance. And so for that, we've developed Amazon Aurora. This basically is stripped out the complete caching and storage layer of MySQL and built a modern database that really works well in the cloud, replicates 6 times over 3 availability zones, making sure that you get consistent low performance out of this database while remaining highly available. Amazon Aurora is the fastest growing AWS service ever. It kind of gives you an indication how eager our customers are to move away from these commercial old-style databases. That in essence, their technology has been developed in the 90s and never has changed since. For that, we also launched Amazon Postgres edition of Aurora to make sure that you can easily migrate from some of these other databases that are semantically so much similar to Postgres in the cloud. Yeah. And actually, I think it's available GA these days, actually. If you look at sort of these customers, I'd like to pick out Expedia here. Expedia runs, 150 travel sites around the world. And they base all of their backends on Amazon Aurora. 300 million writes a day, with loads up to, 17,000 writes a second, 35,000 reads a second, all with consistent performance of around, actually, single tens of milliseconds of writes. So if you have all this data, you really want to get insights into it as well. You know, it's not just a matter of processing transactions. You want to have deep insight into the data that you're using. I think, actually, with all of the things that we've done in the cloud, one of the effects has been that everybody now has access to the same level of compute capabilities, the same level of storage, the same level of databases. None of that is a competitive differentiator anymore. So what we see with many businesses is that what is now at sort of this system level the competitive differentiator? What drives that? It's your data. The quality of the data that you have, the questions that you ask the data, is going to be the competitive differentiator for your business. So doing analytics is extremely important in the future business. And so we give you 3 major tools in this world. Whether you want to do interactive querying with Athena, whether you want to build your unique analytics capability yourself with EMR, or whether you want to do data warehousing with Redshift. So if you look at Athena, it's really built for sort of these exabyte, petabyte scale data sets that lives in S3, and where you can then just do ad hoc queries against, and where you only have to pay for those queries that you really execute. And so it's really intended for a more interactive, ad hoc way of analyzing data that lives in S3. EMR allows you to use these open source tools like Hadoop and Spark and Presto and HBase to build unique analytics capabilities for your particular application that you have in mind, very dedicated. And then you can pick EMR to run this for you, whether it's on 10 nodes or 100 nodes or 1,000 nodes, depending on sort of the data processing that you want to do and how fast you want to get it done. The first set, of course, is Redshift. Redshift is a very different one from the other two. The other two mostly are based around S3. Redshift is a traditional data warehouse in that it often pulls their data sources from other authoritative data stores. It might be your financial data store, and it might be your product data store, and it might be your sales data store. Putting data out of that, and then running data warehousing complex data warehousing queries on those, a very important part of that is referential integrity. Making sure that the products that sit in that database, the product ID, and your sales data and your financial data actually match up. So heavy responsibility, very fast processing of these very complex queries. And many of our customers love Redshift. And Redshift is probably the service that has been iterating the fastest of all of this. Yeah, they've been really on fire in rolling out feature after feature because it's such a crucial point. What we're seeing also is that data warehousing is no longer a centralized service. If you can get just a data warehouse for 2 hours on a Thursday afternoon, business units by themselves will be running a data warehouse instead of having to go to the centralized IT department. Now, one request from customers really that they had is, because you have to move data towards Redshift, whether we couldn't execute Redshift queries on data that lives directly in S3. And so basically, quite a few of our customers have been using S3 as a data lake. That means sort of you push authoritative updates that happen to each of your databases, and each puts all of those in S3 as well. And you may have exabytes or petabytes of data sets there that you want to execute complex queries on, but you don't want to move that data over to Redshift. Yeah, that would be prohibitive, especially if you get into the petabyte size. So for that, we developed something for you called Redshift Spectrum that now allows you to execute these complex queries directly onto data that lives in S3. What you do is, if you have this data living in S3 and use the AWS data catalog, you describe the data in the catalog, and then in Redshift, you can actually point to it as an external table and pull that data directly out of there into Redshift to execute on it. So we've done an experiment with this. This is, in my eyes, a pretty typical complex data warehouse query. Yeah? Although, actually, some of these queries have many more tables. So these are 3 tables. One lives in S3, which is a petabyte table. Yeah? Prohibitive to move that. A petabyte of data living in S3. 3 local ones, probably, was it a fact table and a dimension table and things like that, that probably will sit locally. And then you have sort of a bunch of joins and filters and grouping by and orders and limits and aggregation, all the stuff you do in a very complex data warehouse query. Now, if you code this on a petabyte data set, the almost only alternative you have is to use Hive. If you code this on Hive, it will take you 5 years to run that query. Yeah? Using a 1,000-node AMR cluster. Can you imagine what your bill is going to be after 5 years? Yeah? If you do this with Redshift Spectrum, it will take you 155 seconds. Yeah? Complex data warehouse query on a petabyte of data takes you 155 seconds and costs you about $200. Yeah? A petabyte of data, complex data warehouse query. Pretty amazing. What we saw is that even though we just launched it about a month ago, immediately we saw companies jumping on this and actually processing their extremely large data sets with this. Now, data warehousing, analytics in general, is becoming more and more important, especially when it comes to real time. Yeah, I always thought that there's sort of the data warehousing that looks towards the past, yeah, where most of the tools that we just described look at. And then you have Kinesis and Elasticsearch and others that move much more about the real-time operations. And so I'd like to invite on stage Dan Webb, who's the VP of Engineering of Deliveroo, who's going to talk to you about real-time data processing and real-time insights. Dan.
Hello, everyone. I'm Dan Webb. I'm VP of Engineering at Deliveroo. Deliveroo was started in 2012 by our CEO, Will Shue, and his co-founder, Greg Orlowski. As an investment banker working in Canary Wharf, Will was frustrated that while there were loads of good restaurants in the area, none of them would deliver to him as he worked late into the night in the office. And so Deliveroo was founded to do just that, deliver great food from great restaurants right to your door. In order to fulfill that mission, we maintain a suite of consumer-facing applications that allowed our customers to order food from local restaurants. But behind the scenes, we also orchestrate an international network of riders and restaurants that work together to get that food to you as quickly as possible. In 2012, Deliveroo served its first customer in Chelsea here in London with Will Shue himself, in fact, as rider number 1. And since then, we've grown enormously, both as a business and an organization. If you spent any time here in London or in many other major cities around the world, there's no doubt that you will have spotted our riders whizzing around the streets wearing jackets much like this one. Well, 4 years later, we're now operating in 12 countries, 140 cities with over 1,000 employees, and we're delivering that food 24 hours a day. But ever since Deliveroo was founded, the use of data has been absolutely critical to ensuring that our customers, our riders, and restaurants have the best possible experience on our platform. And our data fits into three main categories of use case. Firstly, we use data to support our team decisions. So experimentation helps us understand the product changes we make. Graphs help our operations team understand and react to trends in data. And agents all across the business, in fact, are running queries on our data set 24 hours a day. Secondly, we use data to support algorithmic decisions. For example, our dispatch engine, which we call Frank, is constantly calculating and recalculating the best combination of riders to orders. It does this using predictions for rider travel time, food preparation times, and so on. And we calculate that using machine learning models which are trained on our historical data. And finally, we use data to give us real-time operational monitoring. Deliveroo operates in living, breathing cities, connecting customers to riders and restaurants. And as you can imagine, this is a very, very unpredictable environment to work into. We make use of real-time data both to see and react very quickly to situations as they arise, and in some cases predict and completely avoid these problems. We've been using AWS products to make this a reality, and I'd like to give you a little bit of the story so far. So, events flow into our application via Kinesis. We do some pre-processing via Lambda, and then we stream all of that out into S3 as our data lake using Kinesis Firehose. Also, those streams are fed into our ETL pipeline, and we are real-time processing that same event data and building tables that feed Snowflake, who is an AWS partner, which we're using as our data warehouse. Snowflake is a great fit for us for a couple of reasons. Firstly, it allows us to scale compute independently from our storage, so we can scale up at peak times and we can scale right down to save money at quieter times. Additionally, it allows us to ring-fence compute for sets of critical users, which is really useful. We can make sure that that data gets to the people that need it most, no matter what the load on our data warehouse is at the time. And finally, we sit Looker on top of that for visualization and general human consumption. Next up, we need to make sure we're training our machine learning models so that our algorithms are operating on the most relevant data. We're doing this using a cluster of applications that sit on EC2, essentially pulling data from Snowflake, computing coefficients, and then writing those back to S3 for consumption via our application. Finally, we support real-time monitoring use cases by tapping the same Kinesis event streams that populate our data lake and feed our ETL pipeline. Typically, they're doing some processing via Lambda or EC2 applications, and then sending it on to tools like Datadog, which we use to set up dashboards and alerts on our operational metrics. But also, we have some use cases where we've built our own clustering monitoring applications, which I'll show you a bit more of in a moment. So AWS has really helped us move from a world where we were struggling to cope with the increasing demands on our data warehouse, and we only had very, very limited access to real-time data, to an environment that not only fits all of the use cases I've outlined, but will continue to support us as we continue to grow at a rapid pace. Our warehouse is currently at 17 terabytes compressed, comprising of 1.8 billion events, but this is growing very rapidly. In fact, this number is already quite out of date, and from the 1 week ago I wrote these slides. We have upward of 1,000 Looker users, but more than 450 of them are active at peak, actively hitting the Snowflake up to like 7,000 times an hour. Finally, we'd like to show you something that the team has built on top of our data platform that we're particularly proud of. It's something we call Frank's Brain. So as I mentioned before, Frank is the name of our dispatch engine. Its job is, given a set of orders and a set of riders, to compute the most optimal combination of those orders and riders, which will result in the food getting to our customers as quickly as possible and our riders being able to earn as much money as possible. Frank's a complex system based on a whole host of machine learning models that we're constantly tweaking and iterating on to improve operational efficiency. But at this point, it's quite a complex beast. And in fact, we often find ourselves asking, what exactly is Frank thinking about this situation? So our team built a tool on top of our real-time streams to show us exactly what's going on inside Frank's brain. And I'd like to show you that. So this is sped up slightly, but we're now peeking inside Frank's brain on a busy lunchtime in one of our central London zones. We're seeing the decisions it's making in real time, as well as predictions it's making about the time it takes for riders to pick up and deliver those orders. If you look closely, you'll see it stacking orders. And where it makes sense, it's actually changing its mind about the assignments it's making in response to events as they happen in real time. It's really helped us debug and understand how our algorithms affect riders and deliveries beyond just changes in overall metrics. And if you'd like to find out more about that, our lead data engineer, Tom Seddon, is speaking at 3:55 in room 6, and we'll go into a lot more detail about this. Also, we're in the startup area. Look out for the delivery hoodies. Come and chat to us. We're hiring, and we might well have some vouchers for you. So thank you very much.
Thank you. Amazing how much the world is changing with respect to real-time insights into the kind of things that you do. You're no longer interested in your inventory levels yesterday. You're interested in what it is right now. You're not interested in what your customer. You're still interested in what your customers are saying about you yesterday, but real-time right now is equally or even more important. I want to correct one thing I said earlier, that I thought that PostgreSQL on Aurora had gone GA. That's not the case. It's an open preview. Means you can all sign up for it and all use it. So we have these 3 building blocks for analytics. So the one that looks back, the real-time ones with Kinesis and Elasticsearch and EMR. And then there's the third pillar that is past, present, and future, is to look towards the future and to make predictions. Basically, the superpower of precognition. The ability, what's the best way to predict the future? Is to look at the past. I mean, that's all the tools we have. And so for many of us, we sit on significant amount of data, very unique data. And it would almost be silly not to make use of that data to sort of make predictions about the future. At Amazon, the retailer, it's obvious, we sit on billions of orders from the past. And we know exactly which of those orders were fraudulent and not, because you know that about the past. You should use that data then to kind of make predictions that when a new order is coming in, that you should give it a fraud score. We know about the past. We know about new products that we've put into our warehouses, and we know what sort of the right levels of inventory were over time. So if you get new products in, you might as well use this knowledge from the past to make sort of predictions about what will be good inventory levels. And so all of this comes together in sort of machine learning and what these days we call artificial intelligence. For me, this is still sort of computer science. It's not scary robots running around and taking over the world and things like that. It's just us being smarter. Being smarter by using data and create models of that data, and then use those models to sort of make predictions. Now, the challenge has been making sure that we have the right data, make sure that we can train them, and make sure then that we can execute those models in ways that we can put data into it and make predictions out of it. So at AWS, it makes it easy. You can put literally petabytes of data into that. And we see also the new data sources being created, especially out of the world of IoT, where all this data is coming together in new data sources to then sort of use that to train that data and make predictions, use that to build models. And then you do validation of those models. It's actually pretty simple. It's pretty simple computer science. What you do is take 75% of your data from the past and then try to predict the other 25%. And that's how you tune your model. Again, this machine learning may seem like magic. It's not. Yeah? And so you tune your model until you're very accurate in predicting the past, with the idea that that might be pretty good prediction for the future as well. So then you have these models, and you can execute them, whether you do it on GPUs and CPUs, or you can put them using Lambda. All of these kind of pieces come together really well there, or on the edge. And so I like to believe that AWS at this moment is really sort of the center of gravity for AI. Because you've got all these platforms available for you to use. Every piece of this, whether it's the hardware, the software, the higher level services, all of these pieces come together. The cool thing is that we've been doing this for 20 years already, and we have a lot of knowledge about it. If you're, hopefully, you're all Amazon retail customers in this room, or at least many of you, hopefully. Anybody not an Amazon customer? Can I talk to you later? But if you've been visiting the Amazon.com or the Amazon.co.uk homepage, you've been exposed to AI. For 20 years already. Your recommendation engine is machine learning. Similarities, machine learning. Customers who bought X, bought Y, machine learning. Abusive review detection, machine learning. Yeah. Inventory levels, fraud protection, counterfeit good detection. All of these kind of things is all machine learning. And we're doing it for such a long time. We've got thousands of engineers have been working on this. And you now see much of the experience that we have in that world come back into AWS as well. And so many of our customers are using AWS as well for many of their artificial intelligence. Netflix, pretty popular here as well, I believe. Netflix has said that 75% of the movies and series watched on Netflix are driven by recommendations. Well, if 75% of your business is dependent on recommendations, it better be really good. Yeah, and it does not take the general public into account, but it takes individuals into account as well. And so this machine learning becomes extremely important as a core to your business. So if I talk about sort of the different pieces of the AI stack, there's a few things I think that have really accelerated in the past years, not just machine learning, because that's something that we've been doing for a long time, but deep learning, where you take more complex data sets, build neural networks out of it. And for that, you needed to have access to what's called general-purpose GPUs, and especially those that have high parallelism, and where the large memories on these GPUs actually also allow very well-performant parallel access to the memory on the GPUs. And so that's sort of the infrastructure pieces that were necessary to sort of propel deep learning forward. Next to that, I think the engines, the deep learning engines, have made significant progress in the past 3-4 years. Yeah, especially, I think, driven by, we now have this massive access to, for example, the P2 instances. Yeah, and we give you this AMI that you can use that have all these engines in it, and whether you want to use TensorFlow or Caffe or Theano, all of them sit in there. At AWS, we've aligned ourselves with MXNet. And MXNet now has become part of the Apache accelerator. So one of the reasons for us for picking MXNet, first of all, because it performed extraordinarily well on the P2s. But there's another reason for that. Remember that earlier on in our conversation, I told you for us it's important to give you choice. Now, many of the other engines in here, like TensorFlow, for example, only allow declarative programming. But many of you want to do imperative programming around these models. Yeah, so we wanted to make sure that you have choice. If you want to run in Python, or do you want to run your models using it from Java, you want to make sure that all of these actually are able to be programmed. And as such, we picked that one that really matches our strategy well in giving you choice. You get to choose which programming language you want to write your AI applications in. And then you've got sort of the platforms that run with this, Spark, Kinesis, ML, all of this. All of these, especially the lower two layers, require still significant data science knowledge. And I think that most of us will never program at that particular level. Yeah, because it requires really good insight in how to use the multiple layers of these deep learning systems. I think most of us will be using sort of vertical systems, services built on top of these platforms. And we launched 3 of them for you to get going with. And it makes it really easy for you to get going. So the first one we launched is Amazon Lex. And it basically does automatic speech recognition and natural language understanding. By the way, if you have one of the Amazon Echoes, so this has the Alexa voice service in it, Lex is actually part of the components that sit in there as well. You know, it takes an audio file, it translates it into text, and then you use natural language understanding to understand what is the intent of this audio, let's say, message, and then execute a Lambda function based on that. Quite a few of our customers are already making use of this, and for example, Twilio is using it to do automatic translation and actions taken on data that actually comes by. Second one is, of course, the same component that also is part of Amazon Alexa, which is the text-to-speech. So often this goes together with Lex. So Lex is the input part, where you try to understand what your customers are doing. And then Polly is the way that you actually are talking back to your customers. Yeah, and if you look, for example, I think one of the ones that I think I'm really proud of in this one is the guys of Duolingo. If you've ever tried to learn programming languages, or not programming languages, languages that we normally speak, yeah? So if you ever try to, if you ever try to learn languages, actually Duolingo has about 170 million users. So in each of those lessons in Duolingo, which is pretty cool, they target different linguistic skills and concepts. And so they've been pushing Amazon Polly through A/B tests with all sorts of other providers and found that Polly was the most natural one. So if your text-to-speech system is being used to teach other people languages, it's probably pretty good. The cool thing in Polly is also that you can sort of annotate it with all sorts of emotions. You can give it emphasis, or you can whisper, yeah, or you can have a pause. And actually, there's also capabilities in there as well to sort of, if you have avatars, to match it really up with the way that your avatar is moving. So really, really cool stuff there to use. And then the third part of this is image recognition. Amazon Recognition is the service, and you can push images to that. We give you attributes in it, and we'll score those attributes on there. This has a skateboard in it, it's sport. We do it with humans. We tell you that this is most likely to be female. It looks like a face. Is she smiling? Sort of we give you scores there. It's not like absolute. This is with the likelihood that this is happening. Yeah. We also do visual search with this. Makes it very simple. You can train it with your data, and then you give us an image, and you can do the search on the image and pull out the right matching images in your database in there. Makes it very easy. Actually, customers have been telling that it goes makes it really easy for them. In this one, C-SPAN was an interesting one. C-SPAN is the public service channel in the US that broadcasts all political proceedings. And so one of their jobs is to really match which politician said what at what particular moment. So they used to do this by hand. It was very laborious and actually took a lot of time and quite a few errors in it. In 3 weeks' time, using recognition, they trained it with 100,000 politicians in the US and now have this process completely automated. All the videos, every 6 seconds, they make a snapshot of an image, push it through recognition, recognize which is the politician speaking here, and then assign to him what is it that that person was saying at that particular moment. And these guys were in the audience when we launched this one. 3 weeks later, they had all of this running. Pretty impressive. It's really easy to use. Go check it out. And so making use of AI and getting deep insights and really putting AI to work today, I'd like to invite Paul Clark, the CTO of Arcado, on stage to talk about how they're integrating AI into their workloads today on AWS. Paul.
Good morning. Slightly bigger than the usual town halls that I normally speak at. Thank you very much indeed for inviting me here today. So Ocado is the largest online-only grocery retailer in the UK. We don't have any shops. Instead, our customers' orders are picked and packed in huge automated warehouses, which are the largest and most sophisticated of their kind in the world, before we deliver them to their kitchen tables in one-hour slots using our own dedicated delivery fleet. And our business is all about making this process of online grocery delivery as simple and convenient as possible for our customers. But that simplicity is delivered through the application of a huge amount of technology and automation. On the left-hand side of the screen, you can see a simulation of one of our first-generation automated warehouses, and each colored square is a crate containing part of a customer order. And there's typically about 8,000 of these crates on the move across 30 kilometers of conveyor at any one time. And on the right-hand side of the screen, you can see a view of our production day from the perspective of our delivery fleet. Each trace is a customer route taking place, and each little water droplet is a customer drop, albeit significantly speeded up. And almost all the software that powers our end-to-end platform is built in-house by my division, Ocado Technology. We buy almost nothing, and so the cloud services that we now buy from AWS are very much the exception rather than the rule. Our technology estate is very broad and very deep. It spans areas such as e-commerce, supply chain systems, real-time warehouse automation, van routing, robotics, machine learning, big data, simulation, plus many others. So as the fusion of a retailer and a technology business, we're really in the time travel business. We're about giving customers back the time they would have wasted traipsing around a conventional store. But in our new automated warehouses, the first of which went live at the end of last year, instead of many kilometers of conveyor and lots of specialist hard automation, what you'll find there are swarms of robots whizzing around on top of a grid of storage bins arranged in stacks. And these robots, they can lower a grab, a bit like a fairground grab, but one that actually picks something up. And they can bring it up into the body of the robot, and then the robot can move to another square on the grid, deposit the bin onto the top of a stack. But they can also bring these bins out to special machines that live on the outside of the grid, such as a pick station where a human, or indeed another kind of robot, can pick items from a bin into a customer order. Or a decant station where goods coming in from suppliers are decanted into bins and then put into the grid. And to give you some idea of the scale, these grids can be the size of several football pitches with thousands of robots on them. And the robots, they collaborate in swarm-like behaviors. They help each other to allow us to pick a typical order for us, which is 50 items, in just a few minutes. And they're controlled by what is now the densest mobile network in the world, and they're orchestrated by a sophisticated piece of machine learning-based air traffic control. And these systems are solving a 4D optimization problem. You've got the 2D problem of the grids, of the robots on top of the grid as they whiz around. You've got the 3D of the storage grid itself. But it's a 4D problem because we're actually optimizing the grid, looking ahead in time, both as new customer orders are coming in, but also as new supplies are arriving. And we're in the process of building a completely new platform, the Ocado Smart Platform, or OSP, which we will use not only to re-platform our UK businesses, but also to provide bricks and mortar grocery retailers around the world with a shortcut to moving online. And OSP is a combination of this swarm robotics technology for building these warehouses and our end-to-end e-commerce fulfillment and logistics platform rewritten to run in the cloud. Now, moving to the cloud has delivered us numerous benefits, many of which we've already touched on today, such as increased agility and productivity for our engineers, increased flexibility and scalability for our business, access to best-of-breed cloud-based middleware and services, a scalable and cost-effective destination for all our data, and increased security and resilience. The OSP architecture is comprised of hundreds of microservices, many of which are running on the AWS cloud platform. We're currently using 28 of the AWS services intensively. We're using Amazon VPC to create the separate environments for each retailer. We're using Elastic Beanstalk to orchestrate the microservices that run in EC2 instances. We're using Elastic Load Balancer to route traffic to a set of active instances across multiple availability zones. We're using Elasticsearch for storing logs, DynamoDB for our NoSQL storage engine for microservices, and Amazon S3 for storing other static files, cache, and configuration data. Kinesis is our messaging bus to stitch it all together and to get the data into our data lake. And we're also now using Lambda, initially for alerts, but we can see all manner of possible opportunities for using serverless compute across this end-to-end platform. And then we're starting now to use some of those new services such as Lex and Poly for all the unstructured data that flows across our platform. And here are a few metrics that have come out of this journey that we've been on. We now find that an experienced developer can go from conceiving of a basic service to having it deployed in production in under an hour. We've successfully tested streaming events via Kinesis up to 100,000 events per second without it even breaking sweat. And on over 20 occasions, AWS have released a feature that we'd only just realized that we needed before we'd even have a chance to mention it to them. And the services, though, that are responsible for the real-time control of the robots require very low latency, and so those run in private cloud on-premise. And here we use containerization technologies such as Docker and Kubernetes to enable us to flex that boundary between private and public cloud. And all of the data from across our platform are streamed into a cloud data lake, not only to provide analytics, monitoring, and oversight, but also to feed our other business services. But we also use this data to feed our many applications of AI across our platform, such as the predictive analytics that help our customers shop faster and with greater delight, forecasting the demand for the over 50,000 different items that we sell, optimizing the more than 2,000 van routes that we drive each day, overseeing and optimizing those swarms of robots across multiple warehouses, plus many others. Now, building AI into your applications, it used to require hiring specialist engineers with PhDs, pizza-stained T-shirts, and wet towels wrapped around their heads. And some specialist applications of AI definitely still do, and we hire quite a number of those. However, for many other applications, the advent of cloud-based AI services have completely democratized access to AI, made it a commodity, and in so doing have redefined a baseline for smartness. Now, for a few cents, you can call a cloud API, pass in some data, and get back a smart prediction or insight. And to take advantage of this new smartness, companies need to be not only collecting the data they'll need to train the models, as Werner's been talking about, but also architecting their applications to be AI-ready from day one. And that's why we're so excited about the range of new AI services available on the AWS platform, because they're bringing AI within the reach of all of our engineers. AI really is the new Java. It's going to be anywhere and everywhere. Thank you very much.
Thank you. I'd like to emphasize something here. We haven't really talked that much this time around about agility and mostly developer productivity. The stories that we hear from quite a few of our customers are that they see developer productivity improve 2 to 3x easily, because you no longer have to wait for your resources and things like that. And remember, it's not just about production. Yeah? I'd like to sort of emphasize something that I've said quite a few times. Agility lives in dev and test. Where you move fast as a business is making sure that your dev and test is able to speed up. And I think there's no better environment to run your dev and test in than in AWS. So, all of these great stories and all the kind of things that we've done, hopefully get you a good view of what we've done in the past, let's say, 6, 7 months. There's one superpower left in all of this. And I think we all want this superpower. Yeah? We all want immortality. Yeah? At least I want it. I want to do this keynote a few more times, if it's up to you, but, you know. But at least I think we want immortality for our businesses. I think we want to build businesses and applications that live for a long time. At Amazon, Jeff Bezos has made it our mission to think about how do you build a business that needs to last 100 years. It's a very tall challenge. Yeah, most businesses are built for the next quarter. And so the only way to really build a business for long term is to align yourself with your customers. To cannibalize your business often in the short term for a long-term alignment with your customers. And it's easy to see how that works in retail. Works in AWS at the same way. For us, it's important that you spend as little money on AWS as possible. That you are architected in the most cost-effective way. Because if that's the case, the likelihood that you're going to be successful is much higher in the long term. And if you're successful, hopefully we're successful with you as well. And you've seen this earlier on as well in presentations that we're a really collaborative company. We work with you. We're investing in your success as much as that we don't just want to sell to you. That's the old world. We want to make you successful using our services. If you're successful, we'll be successful with you. And that's hard enough because, Jeff also said that if we stop innovating at Amazon, we'll be out of business in 10 to 15 years. That means that you have to continue to focus on innovation. And why? Not because there will be another large e-commerce company standing up, but it will be death by 1,000 cuts. Someone will be doing diapers better. Someone will be doing shoes better. And customers have perfect access to perfect information. Look at these household names. They didn't exist 6, 7 years ago. Each night, 450,000 people are spending a night in a room brokered by Airbnb. Any hotel chain would kill for those numbers. These guys didn't exist 7, 8 years ago. All born in the cloud. And it's not just, let's say, these sort of really new style economies, but also ones that are chipping away at traditional institutions. Quite a few of the traditional institutions are not really seen as so very customer-centric. And as such, there's room for new players to come up. Look at you guys here in the UK. Look at Monzo. Yeah? Look at Oak North, Currency Cloud. Yeah? Chipping away at internationally money transfers. Why? Because they're more customer-centric and focusing on a specific thing that customers expect. Monzo was built as a mobile-first bank. Yeah? And as such, they're really successful in terms of that. And so this whole thing, all these new household names, trigger that these large enterprises need to become aware that they need to go for this digital transformation because it's just a quest for survival. On this, probably General Electric is the best example. These are our customers that are going all in on AWS. And so General Electric probably is the best example because they are the only company left of the original S&P 500 that is still in business. 50 years ago, the average lifetime of a company on the S&P 500 was 60 years old. Now, 15 years. Expectation is by 2025, 75% of the companies that are now in the S&P 500 will no longer exist. And competition will no longer be coming just from the other big players that used to be in your market. Maybe coming from a young startup, it will chip away at small pieces of you. GE, Jeff Immelt, who's now the leaving chairman of GE, said one night you go to bed as a manufacturing company, next day you wake up as a software and analytics company. GE's business now is to use analytics as a core of their business to improve their own operations, to offer this analytics, a system called Predix, as a service to their customers that are buying their big gas turbines and things like that. And they're even offering this analytics now to their competitors. GE is becoming a software and analytics company. That's the reason why they have been surviving for so long time. Survival is not about who's the strongest. Survival is the one who can adapt to a new environment. And the thing is that cloud has democratized this whole platform. It's really about how you target your customers and how you work with your customers. And crucial in all of that is to go for this digital transformation. And we help our customers with achieving this. Mostly by listening very closely to you. How do you want to do development? Last year, we launched well over 1,000 new major features and services. All by your feedback, by the way that you want to build your systems, by what you think is still missing from our platform. And the feedback that you've been giving us is crucial to us. It's also crucial to the future of cloud, because we're building this for you to make you successful. And so with that, please don't stop being critical towards us. Give us feedback in every possible way. I'm Werner at Amazon.com. With that, I would like to say, go build, have fun. See you guys later. Bye.